Hello friends, I am Chandan. This is the mechanical engineering handwritten notes. This is my own handwritten notes, which is useful for GATE, ESC, SSC JE, ISRO, DRDO, BARC, and other competitive exam. The PDF link is given on the description. You can download it. So let's focus on the basic concept of thermodynamics. So first, let's try to understand what is thermodynamics. Thermodynamics is the branch of science which deals with energy interaction and its effect on the system and surrounding. So it is basically energy interaction on its effect and its effect on the system and surrounding. Okay, and this is also known as science of 3E. 3E means there is a energy, effect and equilibrium. So there is a 3E is there. There is a energy, effect and equilibrium. Now let's try to understand what is heat. Heat is disorganized form of energy. Heat is disorganized form of energy. And what is work? Work is known as organized form of energy. And the primary aim of thermodynamics is to convert disorganized form of energy into organized form of energy. So this is the aim of thermodynamics. Okay. Now let's understand what is system. What is system? So system is the fixed mass or volume in space where our study is focused. Okay. So suppose this is our system. When we focus on any particular mass or volume, then this is known as system. Okay. Now, open system, there is a open system, closed system, and isolated. Three system is there: open system, closed system, and isolated system. Open system means that is mass and energy can transfer through the boundary. What is system surrounding boundary? We will discuss later. So, open system is basically known as control volume or flow mass because mass is transferred through the boundary. Mass and energy can transfer through the boundary, and closed system is also known as control mass or non-flow process. Okay, now let's try to understand what is surrounding. Everything external to the system is known as surrounding. Everything external to the system is known as surrounding. Basically, suppose this is our system, this is our system, and everything external to the system, so this is our surrounding. So outside this system, the outside system is known as surrounding, and system or surrounding in between, there is a boundary is there. This is known as boundary. Okay, so what is surrounding? What is surrounding? Everything external to the system is known as surrounding. And so here there is a system, and there is a system, and there is the outside of the system, that is known as surrounding. And here this is known as boundary. This is known as boundary. And the system plus surrounding is known as universe. The total system plus surrounding is known as universe. So here there is a note point is, remember, that is the part of surrounding which directly affected by the system is known as immediate surrounding. The part of the surrounding which directly affected by the system is known as immediate surrounding. Now here the universe is equal to system plus surrounding. The total universe is equal to system plus surrounding. System means where our study is focused, and surrounding is that outside of the system is known as surrounding. Outside of the system is known as surrounding. Okay, now what is boundary? Boundary is the separation between system and surrounding is boundary. Okay, so boundary, there is a various boundaries there. There is a real boundary, real and movable boundary, that is flexible boundary, imaginary boundary. So let's try to understand what is boundary. Suppose this is a rigid wall. This is a closed system rigid wall, and we focus on the only the system. There is a rigid wall. Okay, and the suppose inside this rigid wall there, this is my boundary. Okay, so system means where our study is focused, and the velocity of this system is 0. Here the velocity of the system is 0. So here there is a real boundary is there. So you can say that this is the real and fixed boundary. Fixed means the velocity is 0. That is why this is known as real and fixed boundary. Now suppose there is another fixed boundary. There is a rigid boundary, sorry, this is the rigid boundary, and the velocity of this boundary, that is v. Now inside this rigid wall there is a consider this is a boundary. Okay, inside this rigid wall, this is our boundary. So this is known as real and movable. Real and movable, you can say that this is the flexible boundary. Now there is another things. Suppose this is a one pipe and fluid is flowing inside this pipe. Consider this is a section 1 and this is section 2. Imagine that this is our system. So we imagine this. So this is known as imaginary boundary. Now another is that here there is a piston. There is a piston and this is the cylinder of this. Here the gas is inside the piston cylinder arrangement. The gas is inside the piston cylinder arrangement. So there is a gas inside the piston cylinder arrangement. And this is the connecting rod and this is the crank. So here you can, this is the real boundary because this is not the imaginary boundary. This is a real boundary because there is a rigid wall outside this. This is the rigid wall. Okay. So this is known as real boundary. Okay. So we can conclude that boundary may be real or imaginary. So and it may be fixed and or flexible. Flexible means it may movable. Okay. Now let's understand types of system. There is three types of system is there. There is open system, closed system, and isolated system. This is open system, closed system, and isolated system. Open system means when energy is transferred and mass is transferred through the boundary. This is known as open system. There is an example, that is turbine. Turbine is the example of open system because the boundary in turbine boundary, the energy is transferred and mass is also transferred through this boundary. So this is known as open system. Diffuser is the example of open system. Compressor, pump, piston cylinder including valve. So these are the example of open system. Closed system is that when energy is transferred but mass is not transferred, then through the boundary, then this is known as closed system. So what is the example? That is piston cylinder excluding valve. Remember that, piston cylinder excluding valve. And there is a power plant is also example of closed system, and a refrigeration plant is also the example of closed system. Now there is another things, that is isolated system. When energy is not transferred through the system, through the boundary, and mass is also not transferred, both are not transferred through the boundary, then this is known as isolated system. So one practical example, that is thermoflux. Thermoflux is the example of isolated system, and universe is also the example of isolated system. This is very, very important for SSC JE and other competitive exam. Okay, now focus on that. When there is a heat is there, that means you consider that there is a heat transfer is there. When there is a work is there, you can consider that work transfer through the boundary. When there is a mass is there is mass transfer through the boundary. Just remember this, nothing else. Okay, now so previously in open system we consider that diffuser or compressor, pump, turbine, this is the example of open system. So here this is the symbol of nozzle. Here this is the symbol of nozzle. There is an inlet and there is an exit. Inlet means where the fluid is entering, and outlet means where the fluid is outgoing. Exit is there. Now this is the symbol of nozzle. The area, the inlet area is larger than the exit area. So this is the symbol of nozzle, and here this is the symbol of diffuser. This is the symbol of diffuser. Here the inlet area is less and the exit area is large. So this is the example of, this is the symbol of diffuser. Now what is the symbol of turbine? Turbine is also the open system, example of open system. Here there is only inlet is there and there is exit is there. Inlet is denoted as 1 and exit is denoted as 2. So this is the turbine, and this is the turbine inlet. So the inlet, here the area is less and here the area is large. Okay, so this is the symbol of turbine. But in compressor this is just opposite. The larger area will be inlet and the lesser area will be outlet. Okay, so this is the inlet and here this is the outlet. So this is the symbol of turbine and compressor or pump. Same, there is a cylinder, and inside this cylinder there is a piston is there. Piston is connected to connecting rod. There is a crank is there, and these connecting rod are connected through this to the piston by Gaussian pin, with the help of Gaussian pin, and there is the inlet valve and this is the exit valve is there. This is the example of open system. Okay, so this is something about basic concept. Now in next lecture we will discuss another things on basic concept chapter. Thank you everyone.